Добрый вечер. Я, к сожалению, сейчас начну, к счастью, бесплатный урок английского. Я продолжу на английском. Good evening, everyone. I will continue in English, so to make it simple for us. So, my name is Dmytrii Michalchuk, and currently I'm Chief Business Developer at Teslasuit project. And I wanted to talk about how we purpose the project to work for the space industry and perhaps potentially later on the industry, so in space directly. Currently, we created a suit that allows us to transmit real tactile sensations, i.e. the sense of touch, and it also helps with stimulating the muscles and neural endings to provide, to reduce basically muscular atrophy in space and to provide the real sense of being touched and being stimulated to improve the different parameters of the human body. It also provides deeper immersion in virtual reality, and this is what we use for the training on the ground, and this is what we're planning to use it for going into advanced human research program with NASA, which unfortunately I can't go into details yet because it's still kind of in the negotiations phase, so we're already talking and we're already launching it. But very soon we'll be able to announce it, and we'll be speaking about the details of the project. And as a matter of fact, while we were working on the project, we came to a conclusion that it's going to be a hardware platform that will be or can be used by different entities, i.e. the big corporations for training. It can be used by professional sportsmen and the likes for physical training. It can be used in VR, augmented reality, and it can be used as a standalone device. And I will talk through it through details throughout my slides. So currently, Teslasuit includes 6 principal systems that we use for creating this sensation, the sense of touch. It has the haptic system, which is then split onto EMS, which is electrical muscle stimulation system. It uses TENS, which is transcutaneous neural stimulation. It took me a while to learn that term. It has a motion capture, which captures the physical motion of the person, so the skeletal position is read constantly in real time, so we can see what the person is doing. We can record that, we can replay that, and therefore we can then assess as to what the person was doing at what point of time. The biometrical system has given us this kind of data and why, so we can understand why the person's heart rate goes up, or the skin resistivity changes, and why the person is going into the overhype inside the training, or why the person is not responding to the training the way that has been planned before. We've also added the climate control. We think of it as part of haptics. So on Earth, when we're being touched, we actually feel the physical touch, the pressure, but also we feel the warmth. So without the warmth, we think the haptic is not real. So the speed of temperature exchange is how we assess the different materials. We can touch the wood and the metal all in the same room, and we'll feel it at a different we'll feel it as different temperature, but in reality, it's all ambient temperature of the room. And we've added the biometric sensors to better prepare or better calibrate the suit to the wearer, because our skin is very individual. The sensitivity levels are different. Our muscles grow differently, and we have different kind of upper limits of pain threshold. So the pain threshold is what's important for physical training. This is where we don't want to go overtraining, and this is what professional sportsmen will know. It's a very spread out fact that many they think, oh, if we train harder, we'll get better result. In fact, comes the competition, they fail. They fail just because they can't feel their own upper threshold. They can do a lot of work, but that work doesn't actually bring enough benefits to become better. So this is altogether combined, can be assessed by the suit, and can be helped, assisted with through different technologies embedded in the suit. So currently, haptics itself, I've talked about, it generates the sense of touch. It generates the sense of being actually pushed, punched. We can generate the shots. This is for the special training and so on and so forth. And we use electrical muscle stimulation and TENS to generate that sensation. Currently, the haptic sensation, haptic system is also used as a calibration tool to assess which muscles the person has the most developed on his body. So we can map out the entire muscular structure of the person, so to actually begin the training, so to actually provide good biometrical reading, so we could understand what exactly are we reading in the first place. And so that skips a lot of steps to prepare, because previously the doctor, different types of doctors would have to assess the person in order to even understand where to start from and what kind of programs are the most applicable to that person. EMS itself is an interesting technology. It's been used in medical field for over 30 years now. It's mostly used for post-operation recoveries. It's used for physical training, and one of the pioneers in terms of sports or physical training was the well-known Bruce Lee. And there's an interesting story that he nearly fried himself when he was trying the EMS, because back in the day there wasn't even a regulation or understanding how electricity can be used to influence the muscle training. And obviously he used higher levels and he wanted to succeed, and obviously he was experimenting with the technology. But nowadays it's all well regulated, and that there are presets that are well known and shared. And within Teslasuit we follow the most strict program, which is British Health Advisory on Electrical Muscle Stimulation. So our technology is proven to be safe, as well as working on muscular stimulation levels. We use that EMS to provide harder impact, so meaning we can actually influence the muscles to the point where we can make the person lift the arm without actually them doing work. We can push the button on a computer or on the phone, and the muscle will contract, so it actually changes. But if the person was holding on to something before then, and we excite the muscle, and if the person doesn't let go, that feels like a physical training. So he's actually doing work without moving the arm in any side. So that we actually repurpose for physical capability training, where if people have problems, and many people have problems in a stress situation, to actually act and act fast and actually believe in the fact that they're strong enough to act, we train people in virtual reality to A, not to freeze when they are afraid, B, to actually reach out and do the mechanical work, remember how to do it in the first place, because when adrenaline kicks in, people have tunnel vision but also tunnel thinking. They're not doing that final step to actually save themselves or save the others. And so we use that for all sorts of training in terms of capabilities, physical capabilities, and actually believing in themselves. TENS, in its place, actually is being used in the medical field for also around 20 years, and it's being used to reduce the pains from the muscle strain, but also it's a lighter kind of stimulation, and therefore it's used to create a feather-like touch, so people can feel something, that something is touching, but it's not really like a person knocking on the shoulder. And in fact, it works quite well in terms of when people are being trained and when people are being taught to actually feel the presence in the room. Haptics and TENS itself provides a very short communication medium, meaning if somebody touches you, that's happening here in a personal space, that's already on the skin, and it's very difficult to ignore it in the first place. So if somebody taps you on the shoulder, you'll definitely look around, and you will not be able to ignore it, especially if you thought that you're the only person in the room. Think about that. So we use the technology not only to simulate the sense of presence, but it also helps us generating a few good hormones, we call it. It's oxytocin and dopamine, and to actually boost the person's immune system, but it also boosts the brain activity at the same time, and therefore the learning curve improves. So the learning actually becomes so much faster, and people are capable of remembering not only the physical motion from EMS training, but also TENS brings the actual neural level of the brain to learn faster. So the data retention is a lot higher. There are quite a few studies, researchers that prove the fact. Motion capture itself we talked about it. It has 10 sensors, so it actually can record the entire skeletal position and what the person is doing. So natural body language is recorded, but also multiple user tactics can be recorded. So people can be moving simultaneously in a virtual reality room. They can then be given certain tasks to help one another to do certain activities. And those activities can be taught and replayed at a later stage and actually be looked at from every possible angle thanks to the virtual reality space. Talking about biometrics, so far we've embedded the electrocardiogram, ECG, and we have galvanic skin response sensors. Separately, they provide certain data, but it's sort of meaningful. For example, the electrocardiogram, ECG itself, can read the change in the heart rate, but then telling as to why has it changed is difficult without actually supplementary data. And this is what we take from the motion capture system. If the person was stationary, not really doing much, and the heart rate goes up by, say, 30% within 2 minutes, that's a heart attack coming up. That's no-brainer, so we can call for help. Or if the person's actually doing physical work, and the heart rate goes up, the system can then detect as to how much, where is the ceiling of that person, where does he have to go, and shouldn't exceed the levels in his training, so to make it more efficient and actually stop when it's needed and not to overtrain yourself. So within the biometrics, we are also planning to embed the myography sensor, which will actually give us the exact reading of how much work the person has done. But also we're working on a biomechanical system which will be able to actually produce the sensations of rigidity or the objects to have some kind of weight. Although the object is virtual, we can affect the muscle in a way that it will stop the person from lifting the arm, and therefore it will be very close to the weight that we calibrated it against. So we can simulate certain types of activities where people have to push objects, pull objects, and so on and so forth. So to actually help the brain to remember the mechanical steps that need to be taken in order to progress throughout the training simulation. As a matter of fact, we have temperature control. So far, we've embedded the heat control. The cold is a bit trickier to embed, so we're working on this, and it's a technology that's coming up at a later stage. So far, the heat is a good type of sensation because most of the sensations that we feel is actually through heat, because if we feel the real person, that's heat exchange. We feel the objects in the room. Our skin tends to be a bit cooler because it dissipates the vapor, and so we feel like as if our skin was colder than it is, and that's how we feel the objects which are warmer to the feel, to the touch. Talking about how we combine the different systems, you can see it on the slide. Basically, we connect the different systems to actually understand as to why and how people feel this and that, and how we can implement certain technologies. So talking about, for example, TENS and temperature control, we can heat up and apply TENS stimulation to reduce pain, for example. And we can use the haptic sensations plus the motion capture and heat control to provide the real haptics, the feel of the objects. So far, the technological advantages over potential competitors, to which we have only a few companies that are trying separate systems as their major goal. And there are no companies who have attempted to do anything like we do. We have a fully untethered suit, which means it can work in field. It has its own battery. The battery lasts for good 10 plus hours. So it's enough, it's ample for a good day's workout and good day's planning out and training. It has an onboard control processing unit. So actually, all of the computations can be done on the suit. It's a wearable computer. It's got its own RAM. It's got memory. It's got operating system, and so on and so forth. We managed to embed it, to build it up around the dry electrodes, which is another advantage. So no need to grease up, no need to use the gels that the doctor's using for the ECG, for example. We constantly work on the actual ergonomics of the design. So the design has to be easy to put on. It has to be easy to get out. It has to be wearable to the point where it's not disturbing the wearer or the user. And on top of that, we've got fully registered and patented design. So we have a know-how on how to create the electronics without overcomplicating things. And on top of that, and this is the best part, we thought of the suit that it has to come to the hands of the end user at some point. At the moment, it's enterprise only, but we made it machine washable. Because we thought for the gamer, it's not going to be the gamer who will pay for it, it's going to be the mum. And if the mum has to take extra steps to wash it, it's not going to happen. So it's purely machine washable. All you need to do is just take the battery out. No need to do anything else. Just take it off, stick it in the water, and it's ready in 15 minutes. At the moment, we're offering it to the key industries like enterprise training. They said space industry with C is part of the enterprise. We use it, we purpose it for fitness, medical use. We're trying to get registered and get certified for different medical applications at the moment. Talking about first responders training, so the actual awareness training, we're talking about the physical training, and also one other aspect is it improves the brain activity, therefore people are faster to learn things. We're also working on the AI big data analysis. This is the first of its kind device that allows us to collect all types of data, different data, and actually process it in a uniform way, because the system is tuned to each person, and it actually allows for purer data to flow in and then analyze on a mass scale. And obviously gaming is coming, not the last technology, and obviously the gamers understand why they need that before everybody else. We didn't even need to explain. So that's going to be the most fun part, and it's coming. We're working with multiple kids on producing a good blockbuster for each company, and it's coming up later down the line. So the structure of the company, we're registered as VR Electronics with headquarters in London. We have two locations in Belarus. One is located in Minsk, and that's the biggest R&D office. We have a manufacturing facility that's literally been completed 3 weeks ago in Brest in Belarus. It's on the border. And we have, as a little startup, just 90 plus people working for us. So that's a good achievement for us, we think, because it's only took 2.5 years to grow from 7 people to 90 plus. So that's a good result in my mind as a business developer. And if you have any questions, these are the contacts. Feel free, or you can ask them fire away right now. Thanks. What? Where can I get one? Well, when? Next week? Houston? Yeah.
I'd like to correct something you said. I know you said it was machine washable and just throw it in, but you got to use the gentle cycle, I would bet.
Очень короткое сообщение от наших гостей, и потом мы перейдем к автограф-сессии, к неформальному общению, но постарайтесь опять-таки не перегружать работой людей, они работают целый день и не первый день занимаются этим, так что встретьте это одним почтением к их сложной работе.
Well, first of all, we'd like to say happy birthday to Max, our colleague Max.
Where's Max?
Where is Max?
Birthday, Max. Sure. All right.
So, shall we sing together happy birthday to Max? Yeah. All right. Happy birthday to you. Happy birthday to you. Happy birthday, dear Max. Happy birthday to you.
Ну, это твойка. Ну, сейчас, да, можно уже расслабиться и познакомиться друг с другом, спросить про Teslasuit, ну и все-таки подойти, там, подписать, получить автографы, если у вас еще осталось такое желание и готовность.